All right, we're going to take a moment and continue our triangle congruence study. This specific time, we're in chapter 4, section 3, and we're going to talk about angle, side angle, and angle, angle, side, triangle congruence postulates. So let's start with angle, side, angle. If two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. And then we have its buddy, the angle, angle side. So please note the difference. One of them has the side in between the two angles, and one of them, so let's draw that picture so you guys can see. So it would be angle, side, angle. And then the other one is angle, angle, side. So it would be angle, angle, and then the side that's not in between the two angles. Both of them work, so that's fine. Just knowing how to call, because they both have two angles and a side. So just make sure you're getting the order of them correct. So we're gonna take a look at this little, I call this the bow tie. We're gonna take a look at the bow tie. We know that AD is parallel to EC and BD is congruent to BC. So please note, whenever we're given lines parallel, we're going to have alternate interior angles congruent. We always want to drive that train, so be ready for alternate interior angles. So that every time they give you lines are parallel, they want you to figure out your congruent angles. Always, in our number one is our given statement, AD parallel to EC and BD congruent. It's always going to be given there. Step number 2, let's take care of angle D is congruent to angle C. Let's look at what that is. D and C are congruent, and there it is, guys. Yep, alternate interior angles. Whenever you're given two angles that are, or two lines that are parallel, we're going to drive that train all the way to alternate interior angles. Next one, all the way back to chapter 1, angle ABD, that's this one here, is congruent to EBC. It's this one right here. And that is vertical angles. When two angles are meeting at their V, the bottom of their V's, that's vertical angles. And those guys are always going to be congruent. Okay, so now we can claim it. Triangle ABD is congruent to triangle EBC by, and let's just put our, here's this angle, and then next we have the side, and then last we have the angle. So it's going to be congruent by angle, side, angle. Awesome possum. Okay, example 2, is it possible to prove that these triangles are congruent? If so, state the postulate or theorem you would use. So we are going to take a look at the information given, see if we can prove anything about the angle relationships or the side relationships, and then say yes, it's congruent, or no, it's not. So AR bisects CAT. When something is bisected, it cuts it directly in half. And so we know that the angle CAR and the angle TAR are going to be congruent. So let's go with that one. CAR and TAR are congruent. Given to us is this side CA, and it's congruent to TA. That's what this little tick mark means. And then lastly, because RA is sitting right on top of itself, we can say RA is congruent to RA. And so when we put that all together, we got side, angle, and side. And that is a valid postulate, so we say yes. Okay. Next one we have, let me move this guy so we can see it a little bit better. So we have two sets of parallel lines, and remember when lines are parallel, we have angles congruent. So we are going to, I'm going to guess there's a couple ways we could do this, but let's go ahead and do our alternate interior angles first. So if you look at this little black tick mark here, that's congruent to this little black guy down here. And that would be an angle. And then we have this overlapping side, so by the reflexive property, that side is congruent. And then we have the other angle that's created by our alternate interior angles. That's an angle. So for this situation, we can say yes, the triangles are congruent. And then it would be angle, side, angle. Okay, we're looking at C here. We're given that these sides are congruent, so we can go ahead and say yes, the sides are congruent. Then we have this side right here that's also congruent. And then we ask ourselves, what else can we say? We don't have lines parallel, so we can't say that angles are related. We don't have anything else overlapping. So in this case, we cannot prove that these triangles are congruent. This one is our no one. All right, let's look at D. AR bisects CAT. Remember, if it bisects it, that means it creates two congruent angles from that bisection. So that is called, that is an angle. And then this guy right here, it overlaps. So it is our side. AR is congruent to AR by that reflexive property. And then our last side here, CR and RT are congruent because they give that to us. Now we have to look, do we have a side angle postulate? And we do not. So this, as much as we want it to, and as much as the information seems like it's there, this one is also a no. And that is all for this lesson. Have a great day, guys.